Acylation in toluene. A reaction between toluene and acyl halide in presence of anhydrous aluminum chloride. This is today's lesson. In this lesson, we are going to learn what is acyl halide, names of products produced in the reaction, acylation reaction and definition of acylation, and finally mechanism of acylation reaction. So let's get started. The first point is acyl halide, which is also known as acid halide. Let's see what is acyl halide. This is general formula of carboxylic acid. When from carboxylic acid hydroxyl group is replaced by a halide group, then we get this compound. This is acyl halide, general formula of acyl halide. Here this is halogen, chlorine, bromine, etc. and R may be methyl group, ethyl group, phenyl group, etc. Here, when R is methyl group, then we can get, and X is chlorine, then this is a kind of acyl halide. Its name is ethanoyl chloride or acetyl chloride. If this R is ethyl group, then we get this one, which is propanoyl chloride. If this R is phenyl group, this is phenyl group. This is another acyl chloride, which is benzoyl chloride. So acyl halide is the compound which is derived from carboxylic acid by replacing hydroxyl group with halide group. Then the compound is called acyl halide. The first member of acyl halide is this one, acetyl chloride or ethanoyl chloride, then propanoyl chloride, benzoyl chloride. These compounds are called acyl halides. These compounds are also known as acid halides. Let's move on to the next point. Now the point is names of products produced in the reaction. Let's write the formulae of two main products. Firstly, this one, CH3, CO, CH3. Here, if it is considered main compound, then its name is phenyl methyl ketone. Its another name is acetophenone. If this is acetophenone, and methyl group is considered substituent, then its name will be 2-methyl acetophenone. Single word. Here this is carbon number 1 because it is considered main compound and this is considered substituent. So this is 1, this is 2. Its name is 2-methyl acetophenone. Another compound is CH3COCH3. Acetophenone with this substituent. Here its name is acetophenone and this is carbon number 1, 2, 3, 4. So methyl group is at carbon number 4. Then its name will be 4-methyl acetophenone. Single word. This is 4-methyl acetophenone and this is 2-methyl acetophenone. This is mother compound. Methyl group is considered as substituent, which is at carbon number 2. This is parent compound. Methyl group is substituent here, which is at carbon number 4. That is why its name is 4-methyl acetophenone. Its name is 2-methyl acetophenone. These two compounds are the main products of the reaction. Let's move on to the next point. Now, acylation reaction and definition of acylation reaction. Let's write the reaction first. This is toluene. Here methyl group is a kind of electron donating group. This methyl group increases electron density in benzene ring through hyperconjugation. Methyl group increases electron density at ortho positions and at para position. Ortho positions and para position become electronically rich because of the presence of methyl group. On account of this, methyl group is said ortho-para directing group. This is also known as benzene ring activating group. When this toluene is treated with acyl chloride like ethanoyl chloride in presence of anhydrous aluminum chloride, this reagent produces ethanoyl cation. This ethanoyl cation attacks the benzene ring. At the same time, hydrogen atoms from the benzene ring go out as electrophile. Addition of electrophile occurs. At the same time, removal of electrophile takes place. That is why this reaction is called electrophilic substitution reaction. When electrophile attacks the benzene ring, firstly this electrophile attacks ortho position and then para position. When this electrophile attacks this ortho position, then the product is this COCH3, which is known as 2-methyl-acetophenone. Again, when this electrophile attacks the para position, then we get this compound, para position, COCH3. This is 4-methyl-acetophenone, and ACl is formed as byproduct. In this reaction, acyl group combines with benzene ring, replacing hydrogen atom. So, definition of acylation is the reaction in which one or more hydrogen atoms are replaced from an organic compound like benzene with acyl group. Then the reaction is known as acylation. This acylation reaction was developed by French organic chemist Charles Friedel and American chemist James Mason Crafts in the year 1877. Because of this reaction is called Friedel-Crafts reaction. This reaction is named after scientists Friedel and Crafts. Friedel-Crafts reaction or Friedel-Crafts acylation. Now let's try to know reaction mechanism of the reaction. Let's say this is the reaction, acylation reaction or Friedel-Crafts acylation, in which 2-methyl-acetophenone or 4-methyl-acetophenone are formed. Now let's see mechanism of the reaction step by step. Step 1, acyl chloride. Here this is acetyl chloride. Acetyl chloride in presence of anhydrous aluminum chloride. This acetyl chloride undergoes heterolytic fission in carbon-chlorine bond. Electronegativity of chlorine is 3.0, carbon 2.5. In presence of anhydrous aluminum chloride, carbon-chlorine bond undergoes a heterolytic fission. As a consequence, from acetyl chloride we get acetyl cation and chloride ion. When this bond undergoes heterolytic fission, then over chlorine negative charge develops. Over this carbon positive charge grows up. That is why this is positive charge, acetyl cation, and this is chloride ion. Step 2, this chloride ion combines with anhydrous aluminum chloride. Aluminum chloride, which is a kind of Lewis acid, around chlorine 6 electrons. It's a kind of covalent compound, 3 covalent bonds, 6 electrons, which is not octet fulfilled. That is why aluminum chloride acts as Lewis acid, electron acceptor. This aluminum chloride here accepts electrons from chloride ion to form tetrachloroaluminate ion. From step 1, acetyl cation is formed. From step 2, tetrachloroaluminate ion is formed. Now, step 3. Acetyl cation reacts with toluene CH3CO, acetyl cation and toluene. Methyl group increases electron density at ortho position and at para position. Firstly, acetyl cation will attack this ortho position to form this compound. Here methyl group, acetyl cation. As phenyl group donates electrons to acetyl cation, charge over acetyl cation shifts to benzene ring, which is known as sigma complex. Then each carbon atom carries a hydrogen atom each. Because of this positive charge, covalently bonded electrons of carbon hydrogen bond move towards benzene ring to vanish this positive charge, and as a result this hydrogen gets freed as proton and one product is obtained. This is this, which is known as 2-methyl-acetophenone. Step 4. Toluene, another acetyl cation. This time this cation will attack the para position because ortho position and para position are electronically rich because of the presence of electron donating group, methyl group. So this time it will attack the para position to form this compound, methyl group, here acetyl cation, acetyl group, and from this para position hydrogen goes away as electrophile. So from step 3 we are getting one compound, which is 2-methyl-acetophenone, and from step 4 we are getting another compound, main product, 4-methyl-acetophenone. 2-methyl-acetophenone, 4-methyl-acetophenone. Now let's see about byproduct ACl. ACl is formed, which can be shown at step 5. Step 5. Proton, which is produced at step 3 and 4. This proton combines with tetrachloroaluminate ion, which is negatively charged. When this proton reacts with this ion, tetrachloroaluminate ion, then this ion releases chloride ion that combines with proton to form ACl, and from tetrachloroaluminate ion again aluminum chloride is formed. We got byproduct ACl and again we got aluminum chloride, which is unchanged. So in this reaction aluminum chloride acts as catalyst that remains unchanged after the chemical reaction. In this reaction aluminum chloride produces acetyl cation, and after the chemical reaction it remains unchanged. So this is catalyst in the reaction. This is all about acylation in toluene that produces 2-methyl acetophenone and 4-methyl acetophenone. This is all about acylation. No more today. Thank you very much.